identity, which I have told you, and accordingly, have also shared a few pages with you the other day, that magnetism in itself is not a separate identity. But keep it to yourself and keep it as of now, not as a part which you are to, of course, deal with, because this is beyond the purview of ITJ preparatory course. Yet, there are a few questions which do appear in the mind of students. So, just to weed them out, I'm letting you know that magnetism in itself is not a separate identity. What basically it is a relativistic concept. It is a concept which depends on relativity, and it is in relativity studied as relativistic effect of electric field. It is not studied as magnetic field. It is studied as relativistic effect of electric field. And a very short description on what happens. The other day we were dealing with two lines, if you can recollect. Can you recollect, Rich?
Yeah.
I told you about two lines which are infinitely long, and then I asked you place a charge near to them. And we got to see that electric field will be zero on it. There will be no electric field acting because there are two lines side by side kept, and you place charge near to it. So whatever is to produce positively charged line charge will be annulled by negatively charged line charge. Correct, dear?
This was not discussed. You discussed about an elevator, sir.
Why? Elevator, and then I was on this when the connectivity got disrupted. I hope today it is not to happen. So let me reiterate what I was trying to say that day. Some part of it must have been told. The other which I'm into back to, because that should be in consonance with the paper that I have uploaded. So if you look at the paper, I have taken two threads. I was asked to take two threads. And if you cannot look into it now, you'll look into it later. There were two threads taken, infinitely long threads. And then was asked, one being positively charged, the other being negatively, what will be the effect of these threads? Going to these threads, what will be the effect on this charge? That was the question. And we came to the conclusion, no, Krish, I also mentioned this, I remember categorically. Only this part was mentioned. Yes, elevator I was speaking about, true. And also I mentioned about line charge when it got disrupted. I presume. If not, fine, no issue. There are line charges taken and line charges are at rest. So what effect they are to produce? Of course, there will be no effect in agreement, all of you. There will be no effect on the charge Q owing to the infinitely long line charges. Is the class in agreement? Say me yes or no.
Yes, sir.
Yes, sir.
Whatever produced by positive will be neutralized by negative or vice versa, right? Yeah.
Yes, sir.
Now let me ask you, make this line move. Make this line move with V and this charge also move with V, same velocity. Is it okay? Make the line move with V and charge also move with V. Is it okay?
Yes, sir.
Yes, sir.
So if you move line with V and charge also with V, of course, electrically there is nothing going to change. Tell me why.
The
Because
relative parameters are the same.
Electrically, only electrically. Nothing will change. Reason, the line charges are infinite on length. Correct, yeah? Yes, Sonit, you are saying something. What were you?
We can explain it with relative motion also, right?
Yes. Relative motion I am not bringing in as of now. Reason, I am to take the elevator case, which is already there in SC Varma. We'll be discussing about elevator case, then I'll factor in the relative concept. First, simply, very simply, this is more simple than the other case which we'll be discussing after of this. This is moving, this is also moving, and I'm not talking of being anywhere. I'm talking of being on Earth. I'm not talking of being on line charge. I am beginning with being on Earth. I'll go to line charge later. So if I'm on Earth, what will I read of? Effect due to these lines on the charge. Which effect? Electric effect. Is it okay?
Yes, sir.
Effect? electric effect. Got it, dear?
Yes, sir.
So what you want to tell me? Just the electric effect. I'm talking of field. Will the field in any way? What is field due to a line charge? Infinitely long line charge. Lambda divided by twice by epsilon naught r, right? Yeah.
Yes, sir.
Yes, sir.
So it is what? If you look into it, lambda divided by twice by epsilon naught r, and ask yourself, what is changing over here on the charge? Be it in motion or at rest. One thing I'm sure of, that it will be lambda divided by twice by epsilon r. Why? Because neither lambda nor r is to change. Think about it. What I am into stating, please take with pinch of salt. And if you have any question, ask right away. What did I say? I repeat. If I am to take a line charge which is at rest, I'm comfortable in my skin getting the feel as lambda divided by twice by epsilon r, and we have derived it. In case the line charge starts moving, in case the line charge starts moving, and the charge is also moving, and the charge is also moving, and they are moving, one of the line charge. I'm not talking about both the line charge. I'm talking about one of the line charge. I've taken only the positively marked line charge to be in motion. And it is in motion with a velocity equal to v, that of charge. I am still on earth. I am stay put on earth. I ask myself, will there be any effect due to motion of line charge? Will there be any effect due to motion of charge? You refer theory, you get back to me with the equation lambda divided by twice by epsilon naught r. Then I'll counter it, but the charge, line charge is in motion. Charge is also in motion. You will say, they are in motion. But field, if I am to calculate, then field will depend on lambda divided by twice by epsilon naught r. Check it out. It will depend on lambda, it will depend on r. I'm not changing lambda. Charge, line charge, be it in motion. I have not changed lambda. Did I change lambda? No, I didn't change lambda. Did I change r? The position of charge. Charge is moving along the line. It is not moving perpendicular. Along the line. Did I change the perpendicular distance r? To which what will be the answer? No, that also is not being changed. So if lambda is not changed, if r is not changed, then what comes to us is still the effect over here. The effect due to electric field, mind you, and I'm concerned only with electric field because magnetic field as an identity is not known to me as of now. So you will say electric field is still to produce zero effect. Reason, you know. Lambda doesn't change as per our perception. Lambda doesn't change as per our perception. And r, the perpendicular distance, also is not to change. Now, why did I qualify my statement with as per my perception?
Maybe
When you
something
go to
changed.
relativity, when we study about relativity, then we learn that if a length is at rest, if a length is at rest, then the measurement of its length is maximum. So if this chalk piece holder is at rest, then length of, rest means rest with respect to me, then length of this chalk piece will be the maximum which can be measured. Maximum which can be measured from any frame. So we come to a phrase here, and the phrase says rest length is the maximum length. The length which measure of any object, and the object being at rest is the maximum length. Now, till the time the two charges were at rest, length that we were measuring of the charges, any portion of the charge, line charge, it was maximum 2. The moment I start moving one of the charge, what will happen to length? length will shrink. I'm talking of a particular segment. Length will shrink. And if length will shrink, then lambda will increase of that charge. Agreed or not? Length will shrink. And why will length shrink? I am taking a
Yeah.
part of relativity theory. Yes.
Yes, sir. Yes, sir. I
I am
understood
taking
you.
a part of relativity theory, which you will have to take it on face value for now. That if you are talking of a length, you are looking at a length, and with respect to you, the length is at rest, then that is the maximum measurement of length. And if the length is in motion, then of course the length will be shorter than what you measured vis-a-vis you it was when at rest. So when the line charges were at rest, I measured for a particular segment, I got length equal to L. Why I'm saying a particular segment? Because if you take infinite, it doesn't cut ice. So particular segment length was L. Now of that segment, what will be length as it started moving with respect to me? It will be less than L. Agreed, yeah?
Yes, sir.
Less than L. Agreed or not?
Yes, sir.
So 1 remains whatever it was. On lambda, 1 which is at rest is still to read lambda because that is still at rest with respect to me. The other one which started moving cannot read lambda anymore. So what it reads? It reads lambda prime. And what will be lambda prime? Lambda prime is equal to charge divided by length. And that length is less now. If that length is less, what will happen to lambda prime? Lambda prime will be more than lambda. Now with this perspective, think about it. This has got lambda prime and this has got lambda with respect to you. And lambda prime, you know, has got some differential with lambda. And what over here? That differential lambda prime is greater than lambda. Why so? Because the moving length is less than rest length. Is it okay?
Yes,
Moving
sir.
length is less than rest length.
Sir,
So electric field will no more be zero. Yeah. Sorry, you are asking something.
so are we just accepting that length will decrease?
If you will not accept length will decrease there, then you'll have to go through the notes that I have uploaded, which is Lorentz transformation equation. Lorentz transformation equation, Galilean and Lorentz, they are two experimentation valued, I'll say very highly respected experimentations being done. And we proved that Galilean transformation doesn't work. Why? Because Galilean was of the impression that A remains same whichever frame we are in. Acceleration remains same whichever frame we are in, which was counted later. And we got to know that if we are in a frame which is non-inertial, then acceleration changes. So this is something which is based on Galilean, and I'll not go by Galilean because Galilean was proved wrong. So I'll go by Lorentz. Lorentz later was accepted, and according to Lorentz transformation theory, which is what is relativity based on, we come to a conclusion that length doesn't remain same. There is length contraction, and there also is time dilation. And by the way, let me tell you that relativity theory, which we talk of related to mechanics, has got the genesis not in mechanics, but in electrodynamics. It has got the genesis in electrodynamics. It begins with a statement of Einstein, and that statement being, which we'll study in time to come, that if there is a magnet and there is a loop, you move magnet, then there will be a charge develop which will move in the loop, and this charge will be same, or the current which is developed will be same. It will not depend on whether you are moving magnet or you are moving loop, because what it depends on, it depends on relative motion. You move magnet, relative velocity v, you keep magnet stationary, move loop, relative velocity v. So current will remain same. but there is an elementary difference between the two motion. And the elementary difference being, when you move coil, then the area around coil will not get affected. But when you move magnet, then the area around coil will get affected. I repeat, when you move coil, keep a magnet stationary, then area around coil will not get affected. Only will get affected the coil. And if on contrary you move magnet keeping coil stationary, then not only the coil is to get affected, but also the area around coil will get affected. So there was a distinct difference between what we got experimentally. Experimentally, we got to see that there is an elementary difference, but the end result was to depend only on relative velocity. So the genesis of equation which I am talking about, Lorentz transformation equation, has its seed in electrodynamics. And we cannot go in that detail some other time. If you do have, other than the spare, what you get, if you do have where you can exercise your luxury, then we'll go through the notes and accordingly we'll get to know what I'm trying to suggest over here is just a relation between electric field and magnetic field, and it'll serve good if you keep to this, else it is very drawing. Relativity theory is very drawing and is very interesting. So here, what I'm asking you to do is to keep to this, that length will decrease. Any case, and we are dealing with velocity which is comparable to that of light year. So of course, this is not a practical case, but it is nowadays easily achievable. And we need to deal with all these as we are dealing with nuclear phenomena nowadays. And of the 250 nuclear plant that we have, the best 27 we do have in India. So there are many things which we need to somehow negotiate with, one of it being Lorentz transformation equation. And this equation is to tell you that length will contract. If the length starts moving with velocity equal to that of light, anyway comparable to that of light, then you will see the length getting contract. You will see the time getting dilated. Last chapter of S.C. Verma, I'll suggest. S.C. Verma book, all of you have got. So just the last chapter, which is the briefing on relativity theory. Time dilation, length contraction. If length contracts, lambda will increase. If lambda will increase, then can I make the same claim? I ask all of you, can I make the same claim that charge will experience zero electric field? Yes or no?
No, sir.
We cannot make that claim. Then we will get to see that charge is experiencing electric field. You will say, fine, then what was the need of moving charge? Why did you move this charge? If the charge is to experience electric field, that electric field is courtesy movement of line charge. Why are you moving that charge? I'll say I have moved that charge to make you understand that if you calculate effect of electric field, I repeat, if you calculate effect of operational word, electric field, then that effect, the effect will summarize as F is equal to Q into V cross something. So in that effect, when I'll calculate effect of electric field, in that effect, this V, which is velocity of charge, will feature. In that effect, this V, which is velocity of charge, will feature. And the rest of the term, there is a rest of the term. Look at the 3 pages which I have uploaded. There is a term, and that term we understand as B. And B is an abbreviation of magnetic field. That means we say that force that we are getting is Q into V cross something. And that something is what is being treated as B. So B is, or magnetic field is, our figment of imagination. It is not that there was magnetic field. There was only electric field, and we were studying for only electric field. That electric field got us an equation, and in that equation features V, the velocity of charge, cross something. And that cross something is what we henceforth study to be as manifestation. Which manifestation? Relativistic manifestation of electric field. And we say that we will treat relativistic manifestation of electric field as another field, and that field is read magnetic field. In a nutshell, what I am to suggest is magnetic field is not a separate identity. It is a part. It is certain part which we are referring to owing to movement of either the charge particle or the element which is producing it. So when I'm in elevator, an elevator is at rest. Charge is also at rest. I'm in an elevator. Elevator is at rest. Charge is also at rest. What will I find? I'll find that charge to be influenced by electric field. So that charge is influenced by electric field. The charge is in compliance with electric field, it starts moving in the direction of electric field.
So who's given electric field?
Oh dear, we are producing extraneously arranged electric field. As we produce over here, we are producing over there as well, electric field. Got it, on it?
Okay, sir.
So there is electric field and charge as far I am standing. So how will charge move? I know in which direction charge will move. So charge is moving away from or in the direction of electric field. Here away, there in the direction of electric field because charge is positive. So I got charge following a line. Now what we do? We move elevator. If we move elevator, then we will find from the frame of elevator charge to be in motion. Agree? From the frame of elevator, charge will be in motion because elevator is moving with velocity v. So I'll find charge to be moving with velocity v, correct?
Yes, sir.
Yes. So if I find charge to be moving with velocity v, and if I read that this charge is when made to move, it will experience an electric field or not. Of course, charge motion has got nothing to do with electric field. So what I am to say, it is still to experience electric field, and accordingly its motion will be governed. As per me, the motion will not be straight line anymore. Agreed? Straight line means it will not be in the direction of electric field. Agreed? It will be straight line, but not in the direction of electric field. Think about it. Agreed or not? It will be straight line, but not in the direction of electric field. Are you in agreement on this?
Yes, sir. Yeah.
So it is not in the direction of electric field. Okay. It is in the different direction. And that is velocity. You know how to add the two velocities. So you'll be able to add velocity. You'll get to know direction of movement. Switch on the magnetic field now. Switch on the magnetic field now. And ask the person who was on Earth, is your charge getting affected because of magnetic field? Is your charge getting affected because of magnetic field? The person will say, no, my charge is at rest, so it is not getting affected due to magnetic field. Because magnetic field will affect it if and only if charge is in motion. So that person will, which we will establish in time to come, that magnetic field can affect charge if and only if charge is in motion. So that person will say, no, the charge is at rest, so magnetic field is not producing any effect. Okay, I am taking magnetic field as separate identity now, which is the understanding we are to build here. So separate identity, electric field off the scene now. Magnetic field, I am on Earth, charge at rest. I ask the person who is stay put on Earth, charge is at rest. Is magnetic field to affect it? The person says no. Why? Because magnetic field depends on velocity. Velocity 0, no magnetic field effect. Good enough. I'm comfortable. Now the elevator starts moving, right? Yeah. Elevator starts moving. What I find? I find the charge to be in motion. Say yes or no? Say yes or no?
Yes, sir.
So the charge is in motion. I'm in elevator. I'm in elevator. Charge according to me is in motion. And there is magnetic field. Now what you have to say? Will this charge, as per you, experience force or not? Will experience force or not? Yes, dear. Tell me. As per you, the charge
Yes.
is in motion.
Yeah,
As
it
per you, the charge is in motion. And don't say that no, actually it is not in motion, because motion itself is a relative quantity, dear. You can never say something is in absolute motion, correct, or absolute rest. Are you getting it?
Yes, sir.
They are all relative quantity. So when you say that yes, I started moving in the elevator, elevator is moving with velocity v, and then velocity v is the movement of elevator, is the charge as seen by me in motion. You will say yes, the charge as seen by me is in motion. So will affect magnetic field, will there be effect of magnetic field on charge or not? Very simple question. Tell me the answer in yes or no.
Yes, sir. It must be there. Yeah.
Now, which of the two experiment I am to lay credence to? What I am to say? Am I to say that no, I will lay credence to the person who is standing on earth because charge is not in motion? Or I am to say that no, the person who is in the elevator, elevator in motion, is to be reposed faith on? What shall I do? Because their reading being different. Their reading being different, and mind you, you may say that okay, that difference is an obvious. Why? Because I am moving, so I'll find charge to be moving. That is the motion of charge, relative concept. You are moving up, so you'll find charge to be moving down. That is okay. But your motion, you will read vis-a-vis velocity, right? Yeah. So velocity is moving down. But your motion is not to decide on whether that charge will be subjected to force or not, right? Your motion, as per the relative concept that we have built, relative velocity, you will say, what is so big about it? Charge is moving. I'll say, of course, charge is moving. Charge is moving in downward direction. Why? Because you're moving in upward direction. So you should have seen charge moving in the downward direction, which you have. But how is the motion of charge as seen by you directing force? Force due to magnetic field. Because force, the same force, due to magnetic field seen by a person who is on earth is zero. And you, as you are moving, you find charge to be moving, and now you say that that charge will experience force. And according to you, the charge was moving downwards, and as force is inflicted on it, you know what will happen? Charge will start changing its direction. Velocity will change its sense. It will not remain vertically downward. It will keep on changing. So you will find that velocity is changing with respect to the frame that you are in. Such a predicament we are in. Not only it is moving down, it started moving down. And then we said that force will act. Force will act as seen from which frame? As seen from my frame. And as seen from my frame, as force is acting, what will happen? Velocity will keep on changing its direction. And why? I'll come to that. But velocity will keep on changing its direction. And if I am to lay credence to the person who is stay put on earth,